All right, and welcome to Unit 3, Lesson 8 on inclines, example number 2, and this is the second of 2 examples for this lesson. Okay, so in this question, in this example, we have ourselves a block, and it's a 3.4 kilogram block, and it is accelerating up a slope. The slope is 18 degrees upwards. And this block is accelerating at a rate of 2.7 meters per second squared up this slope. Now the question has told us that the coefficient of friction, kinetic friction that is, because this block is moving across the surface, is 0.515. So there's a fairly rough surface between the object and the floor here. And since this object is moving upwards, this value of friction is going to be causing a force of friction in the direction opposite to the motion. So since the motion is upwards on this slope, we can draw on our diagram here a force of friction moving downwards in a direction opposite to the motion. All right. Well, in order to have a force of friction, we need to have a normal force. And in order to solve the normal force, we know that it's coming straight out of the page. Or not out of the page, I'm sorry. It's coming straight or out of the slope perpendicularly. That's what I'm trying to say here. So we can draw on our normal force here. Force normal coming straight out of the slope, perpendicular to it. All right, so that's a good start. Now, I do have my directions drawn on here like an X. Well, the reason for that is our X direction, right here, X going up and to the right and down and to the left here, is due to the fact that our block is sliding up at an angle. This block sliding back and forth is going to represent the X direction. The X direction is just on a tilt here. Similar to the Y direction is as if this block were jumping, it would jump straight up off the slope. And it's at this angle up to the left and down to the right is what we're going to consider our Y direction. All right. So since this is on a slope, our gravity value is going to be a little bit tilted. And that's something that we have to solve. It's actually kind of core to these incline lessons. All right. So the force of gravity, the total force of gravity, pulls this object straight down into the center of the earth. So we can draw our first big line here and label it force of gravity. But the values that we are going to be using more in our question are going to be the y and the x values of gravity. So we can draw one underground here perpendicular to the slope, and we can call this line force of gravity in the y direction, because this perpendicular to the slope direction is our y value. And we can also draw one of these lines parallel to the slope down here. And this value is going to be the force of gravity in the x direction, right? Parallel to the slope. All right. So a couple things to draw on here, and we can get going with this question. This angle inside this little triangle of our gravity is equal to the angle of the slope itself. So this is going to be 18 degrees. And we should note that this triangle is a little right angle triangle in here. Cool. I'll keep red out because our next step in this problem is that I want to solve what the force of gravity is here. All right. Really, I don't think the direction is going to be too important on it because it's going to be the directions of these magnitudes, but to keep convention, I'll probably just use the negative value on this one. So let's say here we have force of gravity, and we've used this formula quite a few times now, so we know that it's equal to mass times acceleration due to gravity, and we can say that this is equal to 3.4 kilos times the acceleration due to gravity, so negative 9.81 meters per second squared. Okay, So we can probably go and safely say that our force of gravity straight down here is negative 33.354 newtons. All right, but why stop there? Why don't we just solve this FGY and FGX value while we're at it? All right, so we can say FGX is our adjacent side. We've got an angle, and we now know FG, which is our hypotenuse. So we can use cosine for that. So we can say cosine of 18 degrees is equal to FGY divided by, well, this value here, negative 33.354 newtons. So our FG in the y direction works out to 31.72 newtons. I'll even put the negative on here, implying that it is in a downward direction. All right. And how about we jump into blue and we solve for our FGX as well. So we can say that this is our opposite side. So it's going to be a sine value. So sine of 18 degrees is equal to FGX divided by negative 33.354 newtons. Okay. FGY works out to 10.31 newtons. And that's also negative here. All right, x direction downward against our motion. Cool. So we've now solved basically this whole triangle. Keep in mind all three of these forces are forces that are actively acting on this block. Well, really, it's one or the other, right? FG is pulling straight down. These are the components of FG. So not all three, but the combination of FGY and FGX makes up FG. All right, let's do some solving. So what do we want to determine here? Well, we know an acceleration and we know a mass of this block, so we can do a little bit in the x direction, right? We know its direction of acceleration, so we can solve an F net value with that. That seems pretty useful. So maybe we jump into that first. What color is going to be there? Let's go red. So let's solve our net x direction first. Let's say F net x is equal to mass times acceleration. Standard formula, and we have both these values given to us. So our F net x is equal to 3.4 kilos times acceleration, 2.7 meters per second squared. All right. Makes our F net x work out to 9.18. Almost makes you think you're dyslexic, right? These 9.81 is what we're always seeing, acceleration due to gravity. This just happens to work out to a value 9.18, so it looks a little bit weird. Okay, we have F net in the x. Now we can use that second F net formula to figure out the second part of this. We can say that, I think I'll just keep using red. F net in the x direction is equal to the sum of all these forces in the x direction. So moving upwards, we've got our unknown force, right? We've got force 1, which is what we're trying to solve for. Downwards here, we have force of friction, which we don't know yet. So we've got some work ahead of us. And also we have FGX. Right? This really we could draw on this block if we wanted. Just keep in mind that it's down here, so we have to remember to put it in. But plus FGX. Okay, well that one we have, right? Check and check. We have both of those. Force net right here. FGX was, oh boy, this is supposed to be FG, not Y. That's supposed to be a little X value here. So let's get that out of there. and put x. Okay. So F1, and in order to solve F1, we have to solve force of friction first. Okay. Well, let's leave this for now and let's come back to this. Let's jump into blue and let's go in the y direction. Because to solve force of friction, we're going to have to solve force normal, and it's in the y direction. So hopefully switching to the y direction, we can figure out what force normal is. So let's go to our standard force net formula. Force net in the y direction is equal to mass times acceleration. Now, this block, there really are no forces acting up and out of this other than the normal force. So this block's not jumping, it's not moving at all in the y direction. So acceleration in the y direction is 0, meaning that force net in the y direction is equal to 0. Anything times 0 is 0, so F net y is 0. Okay, well that was an easy first step. F net y is equal to 0. Let's do F net y is equal to the sum of all of its forces. So we can do that here. F net y is equal to, well, force normals in the y direction. So Fn plus, what else do we have in the y direction? Well, we have the force of gravity y here, plus Fgy. Okay, well, we can sub some values into this formula now. We can say that F net y is 0 is equal to the normal force, which we are looking for, plus Fgy. Well, Fgy happens to be negative 31.72. So minus 31.72 newtons. Well, Fn is equal to 31.72 newtons. So Fn is equal to 31.72 newtons. Okay. There we are. Well, we have force normal now, and we were looking for force of friction. Well, I think we're almost done this problem, because if we're looking for force of friction here, we can say that force of friction is equal to force, well, not force normal first, it's coefficient of friction times force normal. We have both those values, so we can say force of friction is equal to 0.515 times 31.72 newtons. Getting a little bit further into this here, we get our force of friction works out to 16.34 newtons. Cool. Super useful value. Let's go back to red because I think we're about to finish this problem off. We've got these two done already. We just solved for force of friction. So let's sub some values in here. We end up getting 9. Actually, maybe I'm going to start this a little further over because this will take up a little space. 9.18 newtons is going to equal our unknown force. Force of friction is down in this question, right? This is the negative direction. So we're going to say minus 16.34 newtons. And force of gravity in the x direction, also pulling this down in this negative direction. And our Fgx is down here, so this is minus 10.31 newtons. All right. If we take these values, we rearrange them. So basically, we're just adding these values to both sides. And we are going to end up with force 1, or an applied force, whatever you want to call it. This force up here, working out to 35.8 newtons. All right. So really, these questions, you just kind of have to learn to work through pretty sequentially. You have to identify that in order to solve friction in the x direction, generally you have to solve the y direction first in order to get normal force. And really just keep chipping away at the edges of them, and they're going to fill in from the edges inward. All right. That said, that's the end of example number 2 and the rest of this Unit 3 chapter. I won't be doing any lessons for Lesson 9. It's just descriptions on how Newton's 3 laws explain motion, which we largely do in this in the classwork anyways. So that's all for this unit.